Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I read your article about the rise of local LLMs and their impact on generative AI development. It was quite interesting to learn about the benefits of these models. However, I have a few questions to better understand the topic. Can we start with the advantages of local LLMs mentioned in your article?
Certainly. I'd be happy to discuss the advantages of local LLMs mentioned in the article. Local LLMs offer several benefits that make them increasingly popular in the field of generative AI development. Let's go through them one by one. 1. Data privacy. Local LLMs provide a higher level of data privacy compared to hosted LLMs like ChatGPT, Anthropic's Claude, or Google's Bard. With local models, the data remains within the user's device or server, reducing the risk of sensitive information being accessed by external parties. 2. Security. By keeping the LLM locally, organizations can have more control over their data and reduce the chances of data breaches or unauthorized access. This is especially important for industries that deal with sensitive information, such as healthcare or finance. 3. Offline availability. Local LLMs can operate offline without relying on an internet connection. This is particularly useful in situations where internet access is limited or unstable. Users can still benefit from the capabilities of LLMs even in remote or offline environments. 4. Customization. Local LLMs allow for greater customization according to specific requirements. Users can fine-tune the models based on their domain-specific data, resulting in more accurate and tailored outputs. This level of customization is often not feasible with hosted LLMs due to limitations imposed by the service provider. 5. Reduced reliance on external services. Using local LLMs reduces dependence on external services, which can have implications for cost, availability, and potential service disruptions. Local models provide a self-contained solution that is not impacted by the performance or availability of external servers. These advantages of local LLMs make them an attractive option for individuals and organizations seeking more control, privacy, and flexibility in their AI applications.
Thank you for explaining the advantages of local LLMs in such detail. It's clear that there are some significant benefits to using these models. However, I have a question regarding the customization aspect you mentioned. In your article, you mentioned that local LLMs allow for greater customization based on domain-specific data. Could you elaborate on how this customization process works? What parameters and presets are available for users to customize the output of local LLMs?
Certainly. Local LLMs offer users the ability to customize the output based on their specific needs and domain-specific data. This customization is made possible through various parameters and presets that can be adjusted according to the user's preferences. The available parameters for customization vary depending on the specific local LLM model and the tool being used to run it. However, there are some common parameters that are often available across different local LLMs. 1. Top P. This parameter controls the diversity of the generated output by setting a threshold probability. For the next token, only tokens with a cumulative probability higher than the threshold are considered. Higher values of top P result in more diverse output. 2. Top K. Similar to top P, top K also controls the diversity of the generated output. Instead of using a probability threshold, it limits the number of tokens to consider for the next step. Higher values of top K lead to more diverse output. 3. Temperature. This parameter controls the randomness of the generated output. Higher temperature values result in more random and creative output. while lower values make the output more focused and deterministic. 4. Repetition_penalty. This parameter discourages the repetition of tokens in the generated output. A higher value of repetition_penalty reduces the likelihood of repeating tokens, making the output more varied and coherent. 5. Turn templates. Turn templates are predefined structures or prompts that guide the conversation flow in a specific way. They can be used to customize the structure and style of the generated output. In addition to these parameters, local LLMs also provide presets that offer pre-configured settings for specific use cases or output styles. These presets can be selected to quickly achieve a desired output format without manually adjusting each parameter. It's important to note that the availability and specific names of these parameters and presets may vary depending on the local LLM model and the tool being used. Users can refer to the documentation or user guides of their chosen local LLM to understand the available customization options in detail. By leveraging these parameters and presets, users can fine-tune the output of local LLMs to align with their specific requirements, resulting in more tailored and relevant generated content.
Thank you for explaining the customization options for local LLMs. It's interesting to see how users can adjust various parameters to achieve their desired output. However, I'd like to go back to the advantage of data privacy that you mentioned earlier. While local LLMs do offer increased privacy compared to hosted LLMs, there is still a risk of sensitive information being accessed if the device or server is compromised. How can users mitigate this risk and ensure the security of their data when using local LLMs? Are there any specific measures or best practices that you recommend?
When using local LLMs, users can take specific measures and follow best practices to mitigate the risk of sensitive information being accessed and ensure the security of their data. Here are some recommendations. 1. Data isolation. Ensure that the local LLM is installed on a separate, dedicated device or server that is not connected to the internet or accessible by unauthorized individuals. This helps to minimize the risk of external access to sensitive information. 2. Secure infrastructure. Implement strong security measures, such as firewalls, encryption, and access controls, to protect the device or server hosting the local LLM. Regularly update and patch the underlying operating system and software to address any security vulnerabilities. 3. Secure data storage. Use secure storage methods, such as encrypted databases or file systems, to store sensitive data that may be used by the local LLM. This prevents unauthorized access to the data, even if the device or server is compromised. 4. User authentication. Implement strong user authentication mechanisms to ensure that only authorized individuals can access the local LLM and the sensitive information it processes. This can include multi-factor authentication, strong passwords, and user role-based access controls. 5. Regular backups. Regularly backup the data used by the local LLM to prevent data loss and minimize the impact of any security incidents. Store backups in secure locations and test the restoration process periodically to ensure data integrity. 6. Secure communication. If the local LLM needs to interact with other systems or communicate over a network, ensure that the communication channels are encrypted using protocols such as HTTPS or VPNs. This prevents eavesdropping and protects the confidentiality of the data during transit. 7. Secure development practices. If you are involved in developing or customizing the local LLM, follow secure coding practices and conduct regular security assessments to identify and address any vulnerabilities. This includes adhering to software development best practices, such as input validation and output sanitization, to prevent common security issues like injection attacks. 8. Stay updated. Keep track of security updates and patches for the local LLM software, dependencies, and libraries. Regularly apply these updates to ensure that any known security vulnerabilities are addressed promptly. By following these measures and best practices, users can significantly enhance the security of their data when using local LLMs, mitigating the risk of sensitive information being accessed by unauthorized parties.
Thank you for providing those recommendations on how to enhance the security of data when using local LLMs. It's crucial for users to take these measures seriously to protect sensitive information. Now, I'd like to shift our focus to the different model formats mentioned in the article. You mentioned PyTorch, GGML, and GPTQ as examples. Could you explain the differences between these model formats and the advantages and disadvantages of each?
There are 3 model formats mentioned in the article: PyTorch, GGML, and GPTQ. Let's discuss each of them and their advantages and disadvantages. 1. PyTorch. PyTorch is a popular deep learning framework widely used for training and deploying neural networks. It is known for its flexibility and ease of use. PyTorch models are typically saved in a serialized format with the extension pt or .pth. The advantage of using PyTorch models is that they offer a wide range of pre-trained models and are supported by a large community, providing extensive resources and tutorials. It also allows for easy customization and fine-tuning of models. However, PyTorch models can be larger in size compared to other formats, which could be a disadvantage if memory or storage space is a concern. Additionally, PyTorch models may not always provide the fastest inference speed, especially if running on CPU. 2. GGML. GGML, developed by Georgy Gurganov, is a library that allows models to be run on CPU and RAM. GGML models use a technique called quantization to reduce the size and resource requirements of large language models. This format is still in active development and has undergone some version changes. GGML models typically have extensions like Q2, Q3, Q4_0, etc., which represent the number of bits used to approximate the model weights. The advantage of GGML is that it allows models to be run on consumer hardware. Even with limited resources, it provides a good balance between inference speed and model quality. However, GGML models are not as widely supported as PyTorch models, and there may be compatibility issues with newer versions of the GGML library. 3. GPTQ. GPTQ is a quantization format specifically designed for generative pre-trained transformers. GPT models in the GPTQ format are often 4-bit quantized, though some may be 3-bit. They are distributed with a safe tensors extension. GPTQ models can be run with GPU acceleration, providing very fast inference speed. The advantage of GPTQ is its efficiency in terms of memory usage and inference speed. However, GPTQ models may have lower model quality compared to higher precision formats. It is important to note that GPTQ models are specific to GPT models and may not be suitable for other types of models. To summarize, PyTorch models offer flexibility and a wide range of pre-trained models, but they can be larger in size. GGML models provide a good balance between inference speed and model quality, with the advantage of running on consumer hardware. However, compatibility issues may arise with newer versions of the GGML library. GPTQ models are highly efficient in terms of memory usage and inference speed but may sacrifice some model quality. The choice of format depends on the specific requirements of the application, such as available resources, speed, and model quality.
Thank you for providing such a detailed explanation of the different model formats. It's helpful to understand the advantages and disadvantages of each format. Now, I'd like to delve into the topic of running these local LLM models. In your article, you mentioned different loaders, bindings, and user interfaces. Could you explain how these loaders, bindings, and user interfaces work and how they facilitate the running of local LLM models?